So let's talk about one of the most incredible stories in science, the story of how a young, unknown patent clerk, of all people, completely upended our understanding of space, time, and reality itself. This is the story of Albert Einstein and his theory of relativity.
To really get this, we have to start with a mystery that was driving scientists crazy at the end of the 19th century. You see, they had this beautiful, clockwork universe that seemed to make perfect sense, except for one thing: light. It just refused to play by the same rules as everything else, and that one little problem was about to blow everything wide open.
I mean, imagine it's the late 1800s. Physicists are feeling pretty good about themselves. They've got Newton's laws for motion and gravity, they've got laws for electricity and magnetism. It really seemed like they were just putting the finishing touches on a complete picture of the universe. Now, a key part of that picture was this idea called the ether. See, they knew light behaved like a wave, and waves, well, they have to travel through something, right? Sound waves travel through air, ocean waves travel through water. So they figured space couldn't be empty. It had to be filled with some invisible, universal substance, the ether. And if that's true, the next step is pretty logical. If you're moving through this ether, say as the Earth orbits the sun, then the speed of light you measure should change. If you're moving towards a light beam, it should look faster. If you're moving away, it should look slower. Makes perfect sense.
Except, it was totally wrong. In 1887, two scientists, Michelson and Morley, set up this incredibly clever experiment to measure exactly that. They checked the speed of light in different directions as the Earth zoomed through space. And what did they find? Nothing. Absolutely nothing. No difference at all. The speed of light was bizarrely, stubbornly the same, no matter how they moved. And just like that, physics had a huge crisis on its hands.
And this crisis, this giant gaping hole in their perfect theory, that's where our hero enters the picture. Not some famous professor at a top university. Nope. A young patent clerk in Switzerland with a completely wild idea. Yeah, this is young Albert Einstein. He was a bit of a rebel, didn't like being told what to think, and actually struggled to get a job in academia. But his day job, reviewing inventions at the patent office, gave him something priceless: time to think. And in 1905, he used that time to look at this problem with light in a totally new way. Einstein's approach was just brilliant. He basically said, what if the experiment isn't wrong? What if we just believe it? So first, he said, forget the ether. We don't need it. Second, let's just accept that the speed of light is the ultimate cosmic speed limit, and it's the same for everyone, period. But that creates a huge problem. If speed is distance divided by time, and the speed part is constant, then something else has to change. And Einstein made the incredible leap. It must be time itself. There is no universal clock. Time is personal. It literally ticks at different rates for different people, depending on how they're moving. And buried inside this radical new theory, which he called special relativity, was a consequence so profound, so earth-shattering, that it can be written in just 5 simple characters. E equals mc squared. It's the most famous equation in the world, and for good reason. It revealed this deep, hidden truth. Mass and energy are just 2 different forms of the same thing. Mass is like super, super concentrated energy. And this wasn't just some abstract idea. It's the very principle that explains how you can release an unbelievable amount of energy from a tiny bit of matter, a discovery that would literally change the course of human history. But Einstein knew he wasn't done. His new theory was beautiful, it worked perfectly, but it had one massive problem. It completely clashed with the single biggest theory in physics, Isaac Newton's theory of gravity. Okay, so here's the showdown. Newton's gravity was supposed to be instantaneous. If the sun just vanished, poof, we'd feel its gravity disappear at that exact same moment. But Einstein had just set a universal speed limit. Nothing, not even gravity, can travel faster than light. The two ideas just couldn't both be right. One of them had to break. So, Einstein did what he did best. He came up with a thought experiment, what he later called his happiest thought. Picture this: you're in a windowless elevator. You feel your feet pressed to the floor. Now, are you sitting still on Earth feeling gravity, or are you out in deep space in a rocket that's accelerating upwards? The thing is, you can't tell. The feeling is exactly the same. He realized gravity and acceleration are 2 sides of the same coin. And that amazing insight led him to an even crazier, more profound question. What if gravity isn't some spooky force reaching across the void to pull things? What if it's something woven into the very fabric of the universe itself? And here is his breathtaking solution, his masterpiece, general relativity. He said that mass and energy don't create a force. They literally bend and warp the four-dimensional fabric of space-time. Think of it like putting a bowling ball on a trampoline. The Earth isn't being pulled by the sun. It's just following the straightest possible path through the curved space that the sun's massive presence creates. Gravity isn't a force. Gravity is geometry.
I know, that's a mind-bending idea. But in science, a cool idea is just an idea. You need proof. And in 1919, a dramatic expedition was about to show the world that Einstein's bizarre new vision of the cosmos was actually incredibly true.
So a team of British scientists traveled all the way to West Africa to watch a total solar eclipse. Their mission? To photograph the stars right next to the blotted-out sun. And they found that the positions of the stars had shifted. The starlight had actually bent as it passed through the warped spacetime around the sun. And it bent by the exact amount Einstein's math predicted. It was stunning proof. The news went viral, and Einstein became the most famous scientist on Earth overnight.
But there was another bombshell hidden in the math of general relativity. When you apply the equations to the whole universe, they said something impossible. They said the universe couldn't just be sitting there, static and eternal, which is what everyone, including Einstein, believed. No, the equations demanded that the universe had to be on the move. It had to be either expanding or contracting. Honestly, this idea was so weird that even Einstein couldn't bring himself to believe it at first. But then, in the 1920s, an astronomer named Edwin Hubble pointed the most powerful telescope in the world at the sky, and he saw it. Distant galaxies, everywhere he looked, were rushing away from us. The universe really was expanding, and that single observation not only proved Einstein right, it gave birth to our modern story of creation, the Big Bang. I mean, just take a second to think about the speed of this revolution. In 1905, time itself becomes personal. A decade later, gravity becomes geometry. A few years after that, it's proven true by an eclipse. And just a few years after that, we learn that our entire universe has a history, a beginning, and is getting bigger every single second. It's just staggering. You know, that idea of an expanding universe was so completely alien that Einstein actually tweaked his own equations at first. He added a little fudge factor to force the universe to be static. When Hubble proved him wrong, he famously took it back, calling that little fudge factor the greatest mistake of his life for not trusting his own beautiful theory. But here is the final incredible twist to the story. Decades later, astronomers discovered that the expansion of the universe isn't just happening, it's speeding up. And the mysterious force pushing everything apart? Well, it behaves almost exactly like Einstein's so-called greatest mistake. It seems even Einstein's blunders were more brilliant than most people's successes. And it just goes to show you, the story of relativity is far from over.